With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Here the given question is, if z is equal to cos phi plus iota sin phi for all phi belongs from pi by 3 to pi, then value of argument z square minus z is. So let's find it. So firstly here z is given as cos phi plus iota sin phi. So let's whole square it. So z square become equal to cos phi plus iota sin phi whole square, right? So here let's open the whole square. So here it is become cos square phi plus iota square sin square phi plus 2 iota sin phi into cos phi. Now here it is equal to cos square phi minus, now here iota square is minus, so minus sin square phi plus 2 sin phi cos phi into iota. Now here we know that the cos square phi minus sin square phi is equal to cos 2 phi. So right here cos 2 phi plus iota. Now 2 sin phi cos phi is sin 2 phi. So right sin 2. So here we can write our z square minus z, or we can write z square minus z as cos 2 phi minus cos phi plus iota sin 2 phi minus sin phi. Now we have to find so here we have to find argument of z square minus z. So to find argument, we know that we have to firstly check whether this complex number lies on which quadrant, right? So here let's check. Here it is given that our phi belongs from pi by 3 to pi. Let's check cos 2 phi minus cos phi lies on which quadrant. So to check it, let's put any value of phi between pi by 3 to pi. So here I am going to put the phi is equal to pi by 2. So when you put phi is equal to pi by 2, cos 2 into pi by 2 become equal to cos pi, and it is cos pi by 2. Now here cos pi is equal to minus 1 and cos pi by 2 is 0. So we get cos 2 phi minus cos phi as negative. Now here let's check at pi by 2 sin 2 phi minus sin phi. So sin 2 into pi by 2 minus sin pi by 2. Here sin 2 will cancel out 2 and sin pi is 0, you know, so it will again give you negative value, so it is also negative. So we can say that this complex number, that is z square minus z, lies on fourth quadrant, right? So in fourth quadrant we know that the argument of z square minus z is given by tan inverse mod of y by x minus pi. So our argument of z square minus z become equal to tan inverse of, now here the value of y is sin 2 phi minus sin phi, sin 2 pi minus sin phi divided by the value of x is cos 2 pi minus cos phi minus pi. Now this become equal to tan inverse of the formula of sin 2 phi minus sin phi is given by 2 cos x plus y by 2. It means 3 phi by 2 into sin x minus y by 2. It means 2 phi minus phi by 2. So it is phi by 2 divided by the formula of cos 2 phi minus cos phi is given by minus 2 sin x plus y by 2. It means 3 phi by 2 into sin phi by 2 minus pi. So now here these will cancel out each other, sin phi by 2 sin phi will cancel out each other, so it become equal to tan inverse of, here 2 will cancel out 2, and here we have minus of cot 3 phi by 2, now minus pi. Now we know that our phi belongs from pi by 3 to pi, so our 3 phi by 2 belongs from here pi by 2 to 3 pi by 2. It means 3 phi by 2 lies in second quadrant and third quadrant, but here we know that the value for tan and cot is positive in third quadrant. It means So let's see here, we get our argument of z square minus z is equal to tan inverse minus of cot 3 phi by 2 minus pi, and we know that our 3 pi by 2 belongs from pi by 2 to 3 pi by 2. It means in second and third quadrant, but in third quadrant tan and cot is positive, so I can write our cot as tan pi by 2 plus 3 pi by 2, because in second quadrant the tan is negative, so tan pi by 2 plus 3 pi by 2 gives you again minus cot 3 pi by 2 minus pi. And also, so here our argument of z square minus z become equal to, here tan inverse tan theta is theta, so it become pi by 2 plus 3 pi by 2 minus pi, so it become equal to 3 pi by 2. Now pi by 2 minus pi is pi by 2, so the answer is half of 3 pi minus pi. So this is the answer for the argument of z square minus z.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.